Thank you, ma'am. All right, shape stays the same. Center gets multiplied by 2.54. Spread will be multiplied by the absolute value of 2.54. Questions? All right, key to the homework. You had 17 to 22, I believe, right? All right, 17 and 18. Right there. The shadow. Oh my arm. Can I move from 17 to 18? Is everybody okay? Last class was really quiet too, and you guys.
This Monday and the weekend was long.
19 to 22. Which multiple choice did you have? 27, 26, 33, 27. C. No, you had 26. A. Any questions from the homework?
What up, Miss Woodley?
There goes the quiet. Hey, Wesley.
Hi.
Grab a packet. I was just talking about how the class was really quiet, and you walked in and you broke the silence. Thank you. It was really awkwardly quiet. I'm not a fan of that much silence. All right, today we're gonna do a lot of defining. Sorry. I don't like this part of the math that I teach, but why won't it zoom out? There we go. Zoom down a little further for me. All right, density curve. There are two characteristics for a density curve. The first one is that it is a curve that is always on or above the horizontal axis. And of course, I couldn't stay in the box. Area is always exactly 1 underneath a density curve. There's a second N, right? Underneath. Neath. How do you spell underneath?
UNDERNEATH.
Okay. E-A-T-H.
Underneath.
I thought there was an extra N in there.
It's not underneath. It's underneath.
Underneath.
Isn't? Okay.
What?
Sorry. It just doesn't seem right. I thought there's an extra N. That's okay. The idea is the area is always exactly 1. She's not here. Alright, so a density curve describes the overall pattern of a distribution. I'm going to abbreviate distribution. The area under the curve and above any interval of values on the horizontal axis is the proportion of all observations in that interval. What? I'll make it make sense. Don't worry. After writing all that, I didn't think it'd be nice to make you write more, so I took a picture of some information from the textbook. So when it comes to distinguishing the mean and the median of an I can do this. Distinguishing between the median and the mean of a density curve. The median is what we call the equal areas point. So really the point that would divide the area under the curve in half. The mean of a density curve is what is called the balance point. So if the curve was actually made of solid material and we tried to balance it, it would balance at the mean. The median and the mean are the same for a symmetric density curve. They would both lie at the center. The mean of a skewed curve is pulled away from the median in the direction of the tail. We talked about that in chapter 1. Still shows up here. The mean is pulled towards the skewness. May I move it up, please? Alright, so we have a density curve on the left, and we're going to use it to answer the following questions. Part A, explain why this is a legitimate density curve. There are two characteristics of a density curve that we have to show.
It is on top of the x-axis, and its area is 1.
Thank you, sir. So it has to be on top of the horizontal axis, and the area is 1. So it tells us Total area under the curve is 1. Now, the horizontal axis, we're going to assume they do give us a horizontal line that our density curve sits above. So we're going to say that it's above a horizontal axis. Everybody okay if I abbreviate horizontal axis as HA? We've done a lot of writing already. All right, part B, about what proportion of observations lie between 7 and 8. Here's 7, here's 8. The proportion of observations would be the area under the curve in between those values. So it was shaded darker, but it was kind of hard to tell in the black and white. So I shaded it in a little more. They tell us right here the area is 0.12. So 0.12 of all observations, excuse me. Am I off the screen? Not quite. There we go. Fall between 7 and 8. Now, in your homework, it may not say proportions. What's another word for proportion that we could use? Percent. You may see about what percent of observations lie between 7 and 8. Same type of question, but instead of saying 0.12, I should say 12%. Any questions so far? Yes. Sure. All right, C says mark the approximate location of the median. The median is supposed to be the equal areas point. It's got a little bit of skewness to the left, so it's not going to be at the tallest point and down. I would say, and I'm doing this in pencil, I've been working in pen, but when this comes up, I like to work in pencil. Does that look like I split it about in half?
Yes.
Thank you. So median, capital M. Questions? Part D, mark the approximate location of the mean. Is the mean going to be at the same place as the median? Is it going to be to the left or to the right of the median? To the left. It's skewed left. And
But
it
there's like more to the right. Okay, yeah,
of the median?
never mind. Because it's average, so you'd be taking the small ones.
Yes. Yeah. So the mean is going to be pulled towards the skewness just a little bit. So I'm going to say that's the average. It does say why do they have that relationship. So something like the distribution is skewed left. I should put a safety word, slightly skewed left. Pulling the mean lower than the median. questions? Now we get to do some more writing. Woohoo! Sorry, Seth. Can I flip? Gosh, it's so quiet today. All right, normal distribution and the normal curve. So this time we're talking about the characteristics of a normal curve. A normal curve is an important class of density curves. Normal curves describe normal distributions. And notice that I capitalized normal. We do capitalize the word normal because, you know, math. Why not break the rules of English too? Here's my favorite one. Normal curves are not normal. They're actually special. The one nice thing, because it is a density curve, the area is going to be 1. All normal curves have the same overall shape. They are symmetric. Unimodal. And bell shaped. So you've probably heard of the bell curve. That is also known as the normal curve. They are completely described by giving the mean and the standard deviation. I'm going to abbreviate standard deviation as SD. We denote this by putting a capital N for normal, parentheses, that's mu, the Greek letter mu. It's now our notation for mean, and then sigma, the Greek letter sigma, which we're going to use for standard deviation. And we put that next to our sketched curve. Because it's symmetric, the mean and the median are both at the center. I don't know why I capitalized median. Don't ask me why. I think I was thinking of using the capital letter M for it, but then I wrote the whole word. Standard deviation controls the spread of your curve. So the larger your standard deviation, the more spread out. Smaller standard deviation, more compact. Yes, Mason? Yeah. May I move it up? Oh, wait a minute. I see people still writing. Ah.
So if this year deviation was like a billion, what did you do?
We draw it the same way. You'll see. Can I move it up now? Alright. So, normal curves can be, of course, it doesn't want to move up, can be represented in many ways, but they do have some properties in common besides ones we just talked about. They all obey the following rule. So if we're working with a normal distribution that has a mean of mu and a standard deviation of sigma, I put a template for the normal curve for you. Anytime we draw a normal curve, we're going to put a capital N. We're going to give the mean and the standard deviation next to it. Approximately 68% of the data fall within one standard deviation above or below the mean. At the center of our normal curve is our mean. So notice down along the bottom I gave you hash marks. The center one represents our mean. The other ones represent 1, 2, or 3 standard deviations above or below. I'm gonna have to turn my paper sideways for a second. So this hash mark above the mean, we would say is the mean plus 1 standard deviation. The one right below it, we would say is the mean minus 1 standard deviation. If I go from those hash marks up, make dashed lines. Between those two dashed lines is 68% of the data under the curve. Approximately 95% of the data fall within 2 standard deviations of the mean.
Why are you saying fall and not falls? You know what I'm saying? Like, data falls within.
I don't know. Yeah. Oh, thank you, DJ. Yeah. I don't know. I'm not good with English or words or grammar or any of that. I just care about the math. I'm going to turn my paper sideways again so my labels don't run into each other. So the means at the center, that first hash mark was plus 1 standard deviation. So the next one would be the mean plus 2 standard deviations. If we drop 2 from the center, that's our mean minus 2 standard deviations. Same idea if I were to make dashed lines up from there. In between those two, pink would be 95% of my data. And then the last one, approximately 99.7% of the data fall within 3 standard deviations of the mean, or falls within. I don't think falls makes sense though.
Falls within.
Yeah.
Makes perfect sense.
Okay. I'm going to turn my paper sideways again. So this last hash mark up here is the mean plus 3 standard deviations. Last one down, mean minus 3. And this one's always hard to make fit on the picture. From there to there would be 99.7% of the data. May I flip? Now we're going to look at an example problem with this. The distribution of ITBS, Iowa Test of Basic Skills vocabulary scores for 7th graders in Gary, Indiana is normal with a mean of 6.84 and a standard deviation of 1.55. Notice how I read that. Capital N tells me it's normal. First number is the mean. Next number is the standard deviation. So this is my mean. This is my standard deviation. First thing that you need to do with these problems is you need to draw a curve. For now, I gave you guys a template in your homework. Do your best to make them bell-shaped. They're not going to be perfect for a while. We'll get used to drawing them. But try your best to make them somewhat bell-shaped. So at the center of my curve, I'm going to put the mean, which is 6.84. And I always turn my paper sideways because my handwriting's too big to make all the numbers fit. So center, 6.84. Standard deviation is 1.55. So I'm going to add 1.55 to 6.84. And I'm also going to subtract plus 1.55. So when I add a standard deviation, I'm at 8.39, and when I subtract, it's 5.29. 8.39, 5.29. Then I'm going to add another standard deviation and subtract another one so that I get two standard deviations above and below. So if I go 2 above, I'm at 9.94, 2 below, 3.74. And then I'm going to go one more above and one more below. So 9.94 plus another standard deviation, and 3.74 minus another one. So 11.49 and 2.19. Everybody good with how I got my numbers at the bottom? Any questions? All right, question A. What percent of the ITBS vocabulary scores are less than 3.74? Show your work. So we want to figure out what percent is less than 3.74. So 3.74 is right here. We want to figure out this shaded area to the left because less than is to the left. I know that between 3.74 and 9.94, I have 95% of my data. If the area under a normal curve is always 1, what's the total percent under the curve? 100. Did you say 200? Okay. 1 is 100%. So remember, you would multiply your number by 100. So 1 is 100%. So there's 100% of the data under the curve. Thank you. There are packets up front still, sorry. We know that 95 sit between 374 and 994. So what percent sits outside that? 5, because 100 minus 95 is 5. Normal curves are symmetric. So if I have 5% in these two little tails, the symmetry tells me that they should have the same amount in each tail. So what percent is in each tail? 2.5. So I have 2.5% right there. And I have 2.5% right there. So what percent are less than 3.74? 2.5%. Questions? B says what percent of the spores are between 5.29 and 9.94. So 5.29 is right here and 9.94 is right there. Now I know that between 5.29 and 8.39 I have excuse me, 68% of the data. Using the same idea, we know 100% is underneath. 100 minus 68 would leave us with what? 32? So 68% is in the middle here, which leaves 32% for these tails. The symmetry tells us they have to be cut in half, so it's half of 32.
16.
Thanks, Seth. 16. So above 8.39 to the end is 16%, and below 5.29 to the end is 16%. That 16% includes this 2.5, which means right here, from 8.39 to 9.94, I have 13.5% of the data. 13.5 and 2.5 together give me that 16 that should be above the 8.39. Same idea on the left, I would then know that there's 13.5% between 3.74 and 5.29. Now the question is, what percent are between 5.29 and 9.94? 5.29 up to 8.39 is 68%. And then from 8.39 up to the 9.94 is 13.5%. So when I add those two together, I get 78, 81.5. Questions? Did you decide to do it?
No. I'm gonna remain on mine.
Ask Nolan to do it.
No, you
He'll do it.
do what?
I'm trying to get you all to do math team for me. You and Donnie and Alec, and we could get Landon and Juan. We can get Fernie too, because I have Fernie's second period. Yeah. Yeah.
Wait on that.
Miss Whittle, when does that start?
October 18th.
Only 3
You want to do it?
No, I was just going to tell you if it's anytime soon and Juan can't go.
He said he would do it.
Well, he's
I
got
think
tested
I
for-
I think Juan knows Juan's schedule. He said yes. Because that means he has to do it and Donnie has to do it. So Nolan has to do it.
So he
It's
should be fine by
15
then.
days.
You said the 15th.
18th.
Oh, okay.
What's up, Alec?
Do you want to spot a tailgate for the math team?
Oh.
Great recruit.
No, I will have everybody recruited by then. I'm going to say no. It's on a Wednesday, right?
Yeah.
Yeah, I've got Molly's soccer to take her to. Sorry. All right. questions about these? You guys are gonna try the bottom. Actually, no, you're gonna do that one. You got this. I have faith in you. He was in class last week. No, he was in class last week.
One's fine. He's fine.
Yeah,
He's so sick.
this from the guy who.
Dude, my neck hurts. Hey, I went to the guy. Jeez.
Is that why you were late? Well, they sent a pass for you and you were here.
Well, I did that too.
Okay.
I did that too. Because I'm in Spanish. And I think there's more of some classes. Yeah. It's been like months since I was in class.
Okay. What you mean? No. Honestly. There's not much you can do. Yes, unfortunately. I'll change it tomorrow. So you're gonna add a line, so 2 to 3 times, and put in others, and then subtract it. So you're gonna do 0.26
Never even get that.
and then going subtract.
That would have
Wesley,
Yeah.
you're supposed to be trying these.
So,
What's hard about it?
is this number?
Yeah.
But that's also like I feel normal, which is also always.
Well, I was gonna ask you some bathroom.
No.
Yeah, I'll probably just because. Yeah, it only takes.
For number 33 is
You
just
just swallow
the
yourself.
density curve, like
If
it's like
you are going to show
flat
them.
total, it's still symmetrical. So
Which
like,
one are you looking at?
you have the density curve, my script is distribution, and it's measured by stupid, so I just go like,
Yep. Did you do the last 2 problems?
the last two columns, the exact same thing.
So you didn't label. Yeah, you do.
Huh?
Yeah, you do.
Why don't you do that? So if I get it right, why don't you do it?
Because I am going to assume you copied off and on.
Wait, so when we 35, 33.
Whoa.
Especially the hardest ones in
They're gonna be.
No, they're
Have you
not.
learned anything in this class?
They aren't the hardest problems. Goodness gracious.
Oh yes, I do.
Got a problem with it?
I do. Yeah.
Well,
Where's
from
the-
0.22 whatever to 0.29, that is 68%. And then we know there's 13 months. Hey, Lindsay, will you go down on the book corner, please? No, you haven't done the problem yet. Lindsay's gonna show you guys this one. So, between this one and this one. What's the next little one? So, there's 68 right here, right? Which means there's 32. That means that 16 minus that plus this, there's 13.
So is that it? That's in between?
I just try to
No, I'm always in the math mood.
Why?
Why not?
Why?
Is that me? Well, it depends. If that's me, I don't mind this. That's Mason, it's beautiful. Mason, ignore me. Huh?
That's a really good job.
Not me. It's you.
Ruby's stuck on you.
No, it wasn't no curly hair.
That looks more like you.
That was just more like yours.
Do I like
Now,
explain my
see?
No.
Do I have to write words
Oh,
next to
curly
it?
hair.
No.
How good it be? Yeah, how good it be?
I'm just gonna put on your backpack. No, but you got goofy.
It's yours like longer. That's basically it. I mean,
Make the eyes bigger.
they got the soccer ball right there too.
No, it's that. Put a math book.
Okay, I'm liking
That
it
looks
more.
Oh, that's supposed to be 6 feet.
Oh my gosh, fine, whatever, Leslie. That's your soccer ball?
That looks more like the guy's head from Squid Game. I watched that show.
I've never watched that. I know it's so good. Was it in like Chinese language or something?
It was Korean.
Oh, yeah, that's why.
I watched one episode and yep. It was really stupid.
How do you have to watch an episode to decide that?
Okay. Cobra Kai though.
Oh my gosh, that show was horrible.
Oh, I
It's the same thing every episode.
What is it? Like one person gets out of it and they
Yep, yep.
Yeah.
It's the worst. No snail? I was kind of looking forward to your snail.
I was Netflix.
Sparkly purple.
I'm on Netflix.
I never even
Do you know his name?
Thank you.
His name's Pierre.
Pierre.
Yes.
All right. She labeled the curve for us.
Oh, I forgot to label it.
Well, I wasn't going to call you out on that because you showed all the other work, but yes, you should have this next to it. By label, I meant you put all these numbers down here. There were some kids that didn't do that. Caleb. You need to have a picture. You need to have it labeled if you want full credit. What percent of the batting averages are greater than 0.329? 2.5%. And what percent are between 0.193 and 0.295? That is 81.5. Questions? What, Caleb?
Why do I have to wait?
Because I said so. Because we're going to change it tomorrow. You need to get in the habit of labeling. And we're going to draw them pretty much from here on out to the end of the year. Except for Chapter 4. We don't draw them then. And Chapter 5, because that's all about probability. So we'll take a little break. And then we'll come back to drawing them. All right, homework. You have about 15 minutes. You only have 4 problems, so you could probably finish it all before the bell rings.
I can do